Alright, so many of us struggled on the graded exit ticket. This is not the same graded exit ticket that you have, but I made a new one, and I'm going to go over these questions. Then you'll be able to use this as you revisit your graded exit ticket and hopefully improve your grade. So, on question 1, it says, between which two consecutive whole numbers is the square root of 199? So the word consecutive here means two numbers right in a row. So consecutive days would be Monday and Tuesday, or Thursday and Friday. Consecutive numbers would be like 101 and 102, just two numbers that are right in a row. So I'm looking for two numbers right in a row that number would fall in between. I really think it would be helpful to imagine on a number line, where would that decimal be placed, which two numbers would be on either side. So I'm going to do the square root of 199 and find out that that is 14 and a little bit, 14.1. So it's bigger than 14, but it's not quite up to 15, otherwise this would be 15 and a little bit. So it's bigger than 14, not bigger than 15, so it falls in between 14 and 15. On the second one, which pair of numbers have a value between 10 and 11? So we want to check both of them. We're going to check that and see if they're in between 10 and 11. Basically, we're looking for 10 point something. It's got to be bigger than 10, but not bigger than 11. So it's going to be 10 and then a decimal part. Well, we know the square root of 10 and the square root of 11 aren't going to work. I'm going to show that, but you should understand that that's not going to work. That's a little bit bigger than 3, so that's in between 3 and 4, not in between 10 and 11. Alright, so that one's out. The square root of 100, that's exactly 10, and the square root of 121, that's exactly 11. When it says between, we need something bigger than 10 and smaller than 11, so that doesn't work. We need something specifically bigger than 10 and smaller than 11. And actually, from these numbers inside the square root symbol, you can tell we just need numbers that are going to be bigger than 100 and smaller than 121. So I'm looking at this next option, 101. It's bigger than 100, smaller than 121. 120 is smaller than 121, bigger than 100. It seems like that should work. I'm going to double check just to make sure. Square root of 101, that's 10 and a little bit. It's bigger than 10, smaller than 11. And the square root of 120, same thing, that's really close to 11, 10.95, but that's smaller than 11 and bigger than 10. That's exactly what I was looking for, 10 and a decimal part. Just want to make sure, looking at that last option, square root of 110 is actually a good option. That's bigger than 100 and smaller than 121, so the square root will be between 10 and 11. But this one's a little bit too big. The square root of 121 is 11, so this is going to be a little bit bigger than 11. On number 3, I'm going to shade all the true options. So I really just am going to test a lot of this stuff in the calculator. When you do this in the calculator, the square root of a negative number, it's going to say undefined. Really the best way to describe that is imaginary. That's called an imaginary number. It's not just a negative 10. Really, it's called 10i, but that is not a true statement here. It's not just negative 10. On the second one, I'm going to type that exactly like I see it into the calculator. Negative 5 squared. The negative 5 and the squared part are both in the parentheses. So that's going to come out as a negative 25, not positive 25. So I'm ruling those two out so far. Third one says 7 is a perfect square because 7 times 7 is 49. Well, no, that makes 49 a perfect square, not 7. This is saying the exact opposite. That's the true statement. 225 is a perfect square because 15 times 15 gives us 225. That's a true statement. It's a whole number times a whole number. That's what gives us a perfect square. Next one is pretty straightforward. I'm just going to do the square root of 25. That equals 5. That's a good one. And then the last one, the square root of 100 is 10. 10 squared is 100. So I changed that, and I find that those are not the same. 10 is not equal to 100, so it was just those two options. All right, on number 4, we're going to shade every subset that negative 3 belongs to. So negative 3.0, actually just the way I read it the first time, that's just negative 3. best way to say that is that that is an integer. It's a negative number, but it's not a decimal. Integer is the best spot for it. That's what I'm going to do on the next one. Here I'm looking for every subset that belongs to. The Venn diagram helps a lot here. Integers is inside of rational, and rational is inside of real. So if I say that something's an integer, if it's in that circle, it also must be in this bigger group, the rational numbers group. And these are all going to be real numbers, so we're also going to shade real there. Next one, we're just looking for the best spot for this number. When you do the square root of 50, it is 7.071 going on forever, not repeating the same numbers over and over. That is an irrational number. There is no other word in this list that describes it. Well, at least none of these four describe that number. It is a real number, that's true, but we're not going to shade that because we're just looking for the one best spot for this number. Irrational is the best way to describe that. Number 6, we're looking for every number that is rational. So that means decimals that stop or they repeat. So if I have a decimal that repeats itself or a decimal that stops, that means it's rational. Now remember, this also includes all these smaller groups. It includes integers, whole numbers, and natural numbers because those are really decimals that stop. They're just numbers that stop at some point. So if I notice that something is an integer, like that, it's a number that stops. I mean, you could put the decimal part. If you really need to see a decimal there, you could put 0.0, but those zeros could technically go on forever. But it's a number that has a final digit. That's really what we're looking for, a last number. So that is rational. Another way to think about it is that it's an integer, and all integers are rational. 12 divided by 4, that is 3. That's a whole number. It's a natural number. It's an integer, which means it has to be rational. This one is a decimal that goes on forever. We have the 3 dots. It's not repeating the same numbers over and over. We have the 6 twice, but it's not repeating the same number over and over. That's an irrational number. Square root of 49 is just 7. That's just negative 7. That is exactly like this one. It's an integer, and it's rational. This decimal goes on for a while. It has a last number. That means it stops. So it's rational. When you multiply something times pi, you'll find that that is just like pi, where it goes on forever. We're not repeating the same numbers over and over. So it's not doing either of these two things. It doesn't stop, and it doesn't repeat the same numbers over and over. That's an irrational number. 0.3 repeating, that is a repeating number. That's rational. 4,565, that is a number that stops at some point. That's rational. And the square root of 90 is a decimal that goes on forever. The calculator has its limit, but you can assume that this keeps going forever. We are not repeating the same numbers over and over. That's an irrational number. Which of the following statements is true? All decimals are irrational. Well, we just saw that. That's not true. We have rational numbers that are decimals. All integers are negative numbers. So when we think about the classic integers, those are negatives. But inside of the integers group, we have natural numbers. So the numbers 1, 2, 3, those are integers. So not all integers are negative. Some of them are negative. Some of them are positive. There's no decimals, but they could be positive or negative. All rational numbers are integers. I'm going to draw another version of this diagram. Rational numbers is the big group, and inside of that we have integers. So that's saying everything in rational numbers is also in integers. Well, 1/2 is a decimal that stops, so it's rational, but it's not an integer. That doesn't include any decimals. Some whole numbers are natural. Actually, most whole numbers are natural. I'm going to draw that diagram one more time. Whole numbers is the big group. Natural numbers is the smaller group inside of there. So there are some numbers that are whole numbers, and they're also natural, like 1 and 2. 0 is the only one that's a whole number and not natural, but some whole numbers are natural. That one's true. You can see these diagrams are really helpful. Just draw the two groups that we're talking about, whole and natural, and see how they compare to each other. All right, the last one. We have these 5 numbers to sort into their appropriate groups. We want to see who of these 4 students did this correctly. I'm actually not even going to look at their responses. I'm just going to do this on my own and see who did it correctly. 1 out of 17. That's going to look weird. There's one thing I didn't talk about on the front page that I probably should have mentioned. I just didn't have to deal with it. I mentioned that rational numbers are decimals that stop or they repeat. Another way to think about that is that it is a ratio or a fraction. All fractions are rational because they can be turned into decimals that stop or repeat. Any fraction is rational. It doesn't matter if it looks like a crazy decimal. You might not recognize it here. I don't see it there, but this actually is a repeating decimal. Even though we don't recognize it because it's just too many numbers to repeat, it will repeat, but all fractions are rational because the word ratio means fraction. So I know that that has to be rational. Negative square root of 49, that is just the number -7. That one is an integer. Pi is the irrational number. It goes on forever, doesn't repeat. 5.0, you have a decimal part, so you might be thinking it's in one of the bigger groups, but that's really just the number 5. That is a natural number. And then negative 2.5, you might see that negative and think it's an integer, but we have a decimal. So it can't be an integer, can't be a whole number, can't be natural, because it's got a decimal part. It's a decimal that stops, which makes it rational. Alright, so I'm looking for 1/17 in rational. Good, good, good. Alright, so everybody got that part. I'm looking for pi and irrational. I just noticed that everybody has that one already. The square root of 49 should be an integer. Good, 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 good. Actually, nobody's wrong so far. 5.0 is natural, so we're good with Royce and Jeffrey. Sorry, Jaden, Joseph. They did not get that right. Last one. Is that an integer or it's rational? It's a decimal that stops, so Royce got it right. It's got to be rational. Hope this helps. If it doesn't, ask some clarifying questions. Use it to go back to your graded exit ticket.